All right, so one of the things I want to talk to you guys about today are databases, right? There's a difference in terms of what different databases do and why they work the way they work. So that's going to be one of the big things that I want you to pull away from today, and that Amazon satisfies two of the conditions for database types that you may want. All right, so given that theory, is if you go, and again, you guys are free to follow along. We're probably going to run into constraint limits of too many, too much, too soon. So, but you do not have to follow along. You can do this anytime between today and Monday. Right? I'm really easy on this one. Right? And it's mostly because we're not going to have class on Friday. I know you guys are all tragically unhappy about that. I apologize for any distress and depression that you may feel.
I don't know what to do with my Friday morning, man.
You know, I'm going to recommend Jerry Springer, a cup of coffee, and playing around with Amazon Web Services. All right? Jerry Springer and Steve Wilkos make great background radiation. It is an awesome thing. All right, so there's basically two different databases I want you to play with. One is called DynamoDB, and the other one is called RDS. Right? DynamoDB is what's called a NoSQL data store. Right? So that means it's basically one big, huge, flat Excel spreadsheet. Right? There's no specific index to this. If you are running something like SmugMug or Flickr, if you have lots of people uploading lots of imagery data, satellite imagery data, or anything like that, NoSQL will give you the best performance. If you're running something like banking statements and other things, a relational database is going to work best for you. So when someone comes up and says, I want you to build me a database in Amazon Web Services, ask them first, what kind of database do you want? Because they may not understand the differences between the two. All right? So as we kind of go into Dynamo, right? DynamoDB, again, is that whole idea of we're going to create a non-relational database. And this goes all the way back to the 70s when we were still working out a formula called Bacchus Nauer. Anyone ever hear of something called BNF forms? All right, so Bacchus Nauer is a mathematician, and we all love math, right?
No.
All right, no. All right, who basically set up how data is encapsulated, right? So if you look at a modern operating system now, you know, so like Windows 8, Windows 7, some of the newer Linux installs, what they've done is they've basically taken everything down to an atomic level, right? And this is what makes that master boot record of your computer so important. It's going to keeps track of where everything is. But your hard drive can be considered a NoSQL database, right? And your master boot record is the thing that keeps track of where all the data is on your hard drive. All right, so you're essentially going to do that as you kind of go along with it. If you wanted to create a table, just click on table name and test table. All right, and primary key type. You can do a hash in range, a string. You can do so let's just do a string, and we'll just do index for unicorns. Why? Because I like unicorns. All right, I love unicorns. All right, so what you want to do is choose a hash attribute that ensures your workload is evenly distributed across hash keys. Right, so customer ID, things that are identifiable to a certain thing. Yes, ma'am. I'm sorry, what?
What's hash and range?
What is a hash?
No, hash and range. What is that?
Basically, let me keep on going, and we'll get to that here in a minute. Right, so an example is customer ID is a good hash key. Game ID would be a bad choice if most of your traffic relates to a few popular games and all the rest of it. If you have a hash and range, all right, what you can do is basically put in a range attribute name. So you can add something extra to this, which is index for monkeys wearing fezzes. Although I probably spelled that wrong. String, it can be a number, it can be a binary, on, off. It can be a binary string. Right, it all depends on how you store things. So if you open up a JPEG image in TextPad, you'll notice the first line of it says what it identifies what kind of type it is, right? Whether it's JPEG or MPEG or AVI. So you could literally take your JPEG as a text file and do a hash of JPEG, and then do a binary index for JPEG types, because it's going to be JPEG 1, 2, 3. Could be AVI, MPEG, and it allows you to index that so that I know if I'm uploading pictures or movies. All right, so you can help define things a little bit better. That's what they mean by hash and range. All right, so we're just going to do a hash here, so we'll just do index for unicorns. Read capacity units, right? So one of the good things they do is they help you calculate how much capacity I need to provision for your database. And this is really, truly important, right? If the average item size is less than 1 kilobit, then we know what to do. But if we wanted to do imagery, the average image size right now, just for an image, is around 32 gigs. 32, right? If I got that right? Yep, so it would be 32,000 K, or 32 million K, right? Estimate 1 to 64. We'll just do 64 because I want to be able to store as much stuff as possible. Estimate read items per second. If you have 1,000 customers coming through per second, how much time do they need to be able to read write? So let's just go ahead and plan on 1,000 customers per second coming through my NoSQL database. Right? If you're running something like Flickr or SmugMug or YouTube, your provision stack is awesomely huge. Right? If you're Netflix, your provision stack is awesomely huge. If you're me, not so much. Right? Estimate the items written per second. Let's go ahead and say that people are uploading 1,000 per. Right? So they want us to put in 64,000 for this. All right. So the throughput capacity of this table will cost me $57,000 per month. Right? So this is a huge honkin' database. So what happens if we drop this? Because that's a little expensive, right? So, so what happens if we drop this down to like 8? And if we're and let's drop this down to 10. And let's drop this down to 10, and then we can let it calculate. All right, and that drops us down to $71.43 per month. So this matters, right? When you're doing a NoSQL database, how much these estimates are pretty dead bang on. And if you don't have $57,000 in your pocket to get started, then this could be a really expensive day for you. Yes, sir.
Isn't that kind of where it would probably make sense if you had that much throughput to have your own servers and someone managing them now?
That would be the risk-reward trade-offs between what you want to do and how you want to do it.
Because like if you spiked at this much once a month, 1 month only, it wouldn't make sense, because you could ramp this up, right? And take it down.
Yep. So again, the thing that makes the difference between Amazon and between having things in your own data centers, handling those huge big spikes. If you know you've got a new product launch, so like when SmugMug released Camera Awesome, which is the Instagram for them, right? You know you're going to see a sharp spike for early adopters. Oh, I got a new toy, shiny. Oh, there's a squirrel, kind of thing. But then you know that your usage is going to taper off. So you could actually set something up here for handling that spike while doing stuff in your own data center.
If you know you're going to have a spike.
Yeah. So when you guys set this stuff up for your thing, try not to cost me $57,000 per month because I don't have it. Right?
So it's not okay then?
Yeah, no. So try to keep it at 8, 10, and 10 on this one. All right.
You leave it at less than 1 KB, it's only 90 cents.
Yep. But this makes a huge difference, right? So what you're doing with NoSQL. All right. So notify me when the tables request provision throughput. So yeah, I want them to let me know if you guys are going to cost me $57,000 this month. Right? I really want to know about this.
So should injury.
Yep. So send notification to
Card number?
dmoral at highline.edu.
So
Right.
you're at DMoral.
Yep.
Oh yeah.
Yeah, because I don't care what you guys do with this email address. I'm really okay with that.
It's your highlight email.
Yeah. Yeah, which is really cool because they got much better spam than I do. All right, so then you just kind of, and then what it does, it goes through and it collects it, right? And then it sets up. So Charlie set up, came to Candy Mountain, right, with 1 and 1, range keys set, creating. So Charlie actually set his up. So he's pretty well good to go. And the big thing will be to watch what your CloudWatch metrics say about what you're doing, okay? Now, on the flip side of this is that your programmer is going to then be going through and writing all the hooks for this so that your web interface or your application interface can then write to this database, right? So if you want to explore the table, you can actually go through and browse all the items that are in the table, right? You can go ahead and grab specific things if you know what to look for by that hash or key value, right? So this is where this makes it a little bit different, right? Because you're using a hash, it's not intuitive. Hashes are basically written by machine to kind of help you out, right? So we're still there. So thank you. If you need to change something along the way, you can modify. So if you didn't set up your basic alarms, you can save that off and go ahead and make the changes. And then it will tank out and be cranky on you if you do things. All right, modify, you can delete the table. You can import a table in if you've already got one. And then you can also export the table out. So remember, when you're importing or exporting, you're actually going to have stuff that's going on to drop it to your S3 bucket, right? And this is a really good way of maintaining a kind of backup on this. You can actually automate this export. So there's always a rolling backup, right? So what you do is you'd back it up and then do an incremental backup every time you get the chance, and then do a monthly full data dump. Just remember, you're going to be paying for it in the S3 bucket. So you're going to want to have an automated cleanup process as part of your S3 bucket as well. So anything that's over 3 months old gets chucked out the window. That way you can automate that data process so your life's a little bit easier along the way. Right? So there's a really kind of just fun things that you can do with this. Right. I'm sorry, what?
Once it's exported, it's not stored at this level, it's stored now.
You have a backup copy on your S3 bucket. It will still be here, but you have a backup copy over here in your S3 bucket. And with databases, it's always a good idea to have a backup as many times as humanly possible, depending on its throughput.
So it's not going to take the whole thing and export it. It's still going to be, it's just going to take a copy of it.
It will just take a copy of it and export it out to your S3 bucket. But databases are really kind of twitchy, so the more you back it up, especially if it's a high-use database, the least likely you're going to use consumer data. Or lose consumer data is a really good way to put that, right? And then when you're ready to kill it, you just go in, delete, yes, delete this table. Also delete any CloudWatch, right? So you'll be in pretty good shape on that one. And then we'll go through and then just go through and delete it when you're done. Right? But then that shuts it down so you don't have to worry about it. So remember, this is just a flat table. The only way to access this table is going to be through API, through a web service that you set up, through an application that you set up. Right? That's the only way you're going to be able to do this. So when I upload something to Flickr or upload something to SmugMug, I'm actually using their web service to go ahead and dump this data into their NoSQL table, and we're good. Right? But you can't get hands-on into this without having to follow along and take a look at what's going on inside the table here. So it kind of makes sense on that really big distinction here when you're dealing with Amazon databases. Kind of makes sense? Maybe kind of, sort of? Okay, now the other one is the databases you guys are familiar with, right? The relational database, things like MySQL, things like MSSQL, things like Oracle, right? Most companies run on the relational database because it makes it a lot easier to manage consumer data, right? You can still do large data calls in this, but if you have what's called a blob, a binary large object, that's part of it, whether it's a program like SOAP as part of an authentication module or a picture or a movie, it's usually better to use a NoSQL database because the throughput and performance is better. If you have a lot of transactional e-commerce site or a medical healthcare records site or a hospital or things like that, a relational database is going to be much easier for you guys to manage the transactions as they happen. Right? So if you're walking along with your little cart of medicine and you scan the medicine and you scan the patient's armband, that says the patient got that medicine at that point it was scanned. And that's a really easy transaction. If I go out to Amazon and I buy a bunch of books, that's a really easy transaction. Right? And that's what a relational database is very, very good at. Right? That's what they were designed around. Most databases work at BNF level 3, 4, or 5 now. So Bacchus now shows the math coming back into this in terms of how it takes data and chops it up. Right? So I have a customer ID, I have a customer name, a customer last name, a customer credit card number, CVV number, expiration date, and then my order. That's a really good transaction. Right. So the relational database, when you just want to go in there, you want to launch a DB instance, and it will ask you, what do you want to use? Right? MySQL, Oracle, Microsoft SQL Server. There are some caveats on this one. If you use the Web Server Edition, they will tell you that there's some licensing policies involved here. So if you decide to bring up a Web Edition and decide to throw GitHub on it, there might be issues later on down the road. Right? So if you just want to do something free and easy, standard MySQL, right? Licensing model, general public license, MySQL, the latest version, whichever one you want to use. DB instance class, we can just use our micros, right? Multi-AZ deployment, do I want to send it across the entire Amazon infrastructure? Do I want to back up on the East Coast and on the West Coast? You can make that distinction here. Right, which is really easy. So if you want to just throw stuff into other data centers, you can. Allow auto version, yes, but it's also dependent on what you're doing. Sometimes people write applications that are dependent on a specific version of the database, right? So you can't shove MySQL 3 into a WordPress database because it needs MySQL 5.5. All right, so there's going to be dependencies between the application you're loading and the database that you're choosing. All right, allocated storage, how much do you want it to store? We'll just choose the minimum, 5 gigs. All right, user provisioned IOPS, and that's how much data I'm going to throw back and forth. So minimum value, it wants large. We don't really want to do large. So we're just going to kind of stick to it at 5 because it's not going to be a really heavy use database.
What's
yes, sir.
IOPS stand for?
Input output processing per second. Input output per second. All right. You have to give it a DB name. Dan's DB. Master username. So just like you would be doing root or something other than your name. So DB Dan. Master password, whatever you want to give it. Don't use e.g. my password. If you give it the thing my password, we're all going to know what it is. All right? So then you just click on continue. It will do its thing. Database name. Dan's awesome DB. Database port 3306. What do you need to do to your firewall rules? Allow it. All right? Choose a VPC. We're not going to put this in a virtual private cloud. Availability zone, no preference, but we can choose if we want to do whichever one. Usually no preference. Option group, default parameter group, right? And then good to go. I would just go ahead and stick with a default MySQL 5.5 because I've got another parameter group in here from some stuff that I was doing that will really mess your day up if you choose it. So if you choose CF test, it will really mess up your day. Right, and then just go continue on that. Backup retention period. How long do I enable automated backups? Yes. Let the computer do the work for you. Right? How many days do you want to retain data? That's all dependent on how much data you're going to collect over time. If you're a high transaction processing kind of thing, then yes, you want to back up every day. If you're kind of lame and weak like I am with blogging and other stuff, I only blog like every 2 or 3 days, I could let it go 10 days and not worry about it. I can lose 10 days worth of data because usually it's about 10 days between each one of my entries. Right? So if I was going to use this for WordPress, I can do my backups every 10 days. Right? Backup window, you can actually choose a specific time based on the stats that come off your blog or your log or whatever you're doing. Or you can just say no preference. Maintenance window, right? No preference. Usually they'll try to coordinate these two things with you. Yes, sir.
Is data, or is it cheaper for Amazon depending on the times that you decide to move data? Like if it's during a high availability time when a lot of people, like during normal business hours, does it cost more?
It depends on how you do it. If you do something called a spot, right? A spot instance is that you pay or you set up an instance to run when everything's the cheapest it can possibly be. So yes, there is a steady curve of noon on Monday is the high usage part, and Sunday afternoons no big worry, right? So yes, you could plot this thing out so that you use that resource on a Sunday afternoon or Saturday morning, and really easily kind of control how much you do spend on this. So yes, using a spot instance or setting up your backup or your maintenance windows when you know that Amazon's going to be slow, yes, you'll get a price discount. All right, and then what it does, same thing as always, it kind of gives you a default on what you've got. Goes through, lets you see what you answered to everything, and then you can just go and click the DB instance. All right. So if you want to make a security group, right? Grumpy Cat. You can then see all the instances that are being created as we kind of go along the way. Thank you for making a 100 gig instance. Reserve DB, right? Purchase a reserve DB instance. In other words, if you've got time, right, to do things like that, you can actually reserve time for your DB instance. You can also create a DB Snapshot when you've got your system up and running. And that's just real simple. Create DB Snapshot. Choose your instance, snapshot name, tester 1, Dan's DB. And then it will create a snapshot once the thing is in its available state. All right. If you want to set up a specific security group, we can actually go through and see what all is involved with that. Connection type, whether it's straight IP or through the EC2 Security Group that you want to choose, right? You can choose your specific security group for what you've got. And then you can also bring up and see whatever events that you've got cooking, right? So you can actually set this up for your security group underneath EC2. What do you guys need to do if you've done that? EC2. Go to security groups, bring up your security group, and if you're going to allow connections from the internet, you have to allow MySQL, and then just add the rule and then apply the rule change, right? So you have to remember to do that as you kind of go through all this. We're not really going to go into parameters, but if you do want to see exactly what they've got cooking, what ends up happening when you go into a parameter group, you're basically looking at what's actually happening with inside the database, for not from just a security group viewpoint, but from the entire database process. So do I want to allow these certain things to happen, or do I want to auto increment? Do I want to do an increment offset? So instead of 1, 2, 3, I do 1, 3, 5. Especially if you're into odd numbers, 1, 3, 5, an offset of 1 is always entertaining. Right? Auto commit, do we want it to auto commit the changes when the person is done making whatever changes to the database? So these are a lot of things that you can set up for your parameters on how that database actually functions. So this is sort of like going through not just the INI file, but this is going through and being a DBA at the point of reference where you're setting this up. So when you guys hit 230, the database class, they should be going through exactly what each one of these things means, right? You can also do some option groups with that, right? So you can change things around if you want to deploy options at the same time you deploy your database. Options would be, do I want to have more than one copy of this up and running? Do I want to allow auto scalability? Do I want to make sure that there's a failover somewhere else on the planet? All right. Do I want to put all my databases in a subnet? That's another really interesting design choice. A lot of companies, when you get and you see what's going on in their data center, all their databases are on this really beautiful subnet, which is really awesome if I'm a hacker, because that's the first thing I'm going to want to go for, is where all the databases are, because that's where all the data is. And because that's where all the data is, they're used to moving big piles of data in and out. They won't notice me if I'm making an extra copy of the backup, right? Because it will look like normal traffic. So you can actually do all your databases on a subnet if you want. You just have to watch it a little bit closer. You can also go through and see whatever kind of events are going on in general. These are general events. Something happened, they were created, they were backed up, they did something at that point. So this is a really good way of seeing gross issues that are going on with your database. And then you can also subscribe to specific events if you want to know what's going on with your database. So we can do Dan's event. We select what we want to do with it. So we want to go and look at Ooh, CPU nuclear meltdown. That looks like a fun event. I like that. Now we can apply it to the instance, the group, the parameter, or the snapshot. So I want to apply this to the actual instance that I'm running, right? So we can select all, DB instances select all. So we can go through and choose all.
Who spelled Necular wrong?
Who cares? But then this creates my event, right? So this creates part of my monitoring event so that when I get going into CloudWatch and I want to see what my databases are doing, we have this ability to go through and take a look and do stuff with it. So it kind of makes sense on the relational versus no SQL, right? So why would no SQL be tons more expensive than a regular relational database? Going once?
What was that one more time?
Why would a NoSQL database be tons more expensive to run than a regular relational database?
More storage.
More raw space. So everyone that said raw space is correct. So the idea behind it is that NoSQL databases just grow monstrously and really, really fast because you're storing what's called, again, that binary large object. So blobs go back right to that 1950s horror movie where you see this big blob of garbage coming out of the movie theater, right? NoSQL databases are specifically designed for very large binary objects. And these objects can go into multi-gigabits, multi-terabits. So you're really asking for a lot of horsepower to process it, and you're asking for a lot of disk space to process it. Yep.
And those don't take a big bandwidth or spare space.
No. Usually with a database where you're going to choke point on a regular relational database is on the ability to process data through the CPU, right? So you're going to want to make sure that your box is beefy enough on the CPU side to manage that whole process for you. Okay. Andrew, I'm going to shut yours down.
Okay.
All right. So when you're done, you can go through, you can take a look at what you got. Then you can go into instance actions, you can modify, you can reboot, or you can delete. So you can create a final snapshot or not, and then you can kill it. And then he's down, and then you're gone. Right? Usually people are going to want that final snapshot off their database when you're killing it, unless you've got backups other places and you know the backups are good. Does it kind of make sense on relational databases? So your goal is to spin up a non-$57,000 a month NoSQL database, please. And then go ahead and spin up any one of the relational databases that you want. The one thing I really want to make point blank, though, is that this isn't like having a database on a box, right? You really don't have direct access to that database unless you go through a program of some sort, whether it's MySQL Workbench, whether it's the Oracle administration page, whether it's the MS SQL administrator for that database. That's really about the only way. You really are just getting a raw database engine and a blank table.
So you would have to add something.
You would have to add
Workstation you're on to access it.
You would have to either have something in the cloud that can access that database through one of the UIs, or you can go through programmatically through APIs and do it.
What do they have in the cloud that you can use?
Nothing. You would have to build that.
Oh, you would?
Yeah. So what you do is to spin up a Windows instance and then manage your MS SQL database. You're doing that way. You could also do a Windows instance and an Oracle database, or Linux and MySQL. It just depends on how you want to do. Oracle kind of straddles that point between I can command and control it through a Linux interface or through a Windows interface. Most people will stick to Windows interfaces because that's what a lot of DBAs are grown up on. Right? They'll stick to MySQL Workbench, the MS SQL Database Manager, or the Oracle Database Manager. Does it kind of make sense? So you guys got plenty of time to do this, and you've got plenty of time to work on your other project with the Oracle Grid Engine. All right? So you guys comfy?
Yeah.
Happy?
No.
Easy going?
Sure.
Maybe? All right. Any other questions? You guys are awesome. Okay. Have at it. Enjoy yourselves.